See, toward this figure, this is a figure of system, surrounding, and boundary. See, this is the part which is taken, this is the region or matter which is taken into consideration or for thermodynamic study. This is known as a system, and this dash line is known as a boundary, and the matter outside this boundary is known as a surrounding. Note that the boundary is the contact surface shared by both system and surrounding. Boundary is the contact surface shared by both system and surrounding. Mathematically speaking, boundary has zero thickness. This is a very important concept point. There may be chance of asking question. They may be asking question. There may be chances of asking question in competitive examination. The boundary has a zero thickness, and thus it can neither contain any mass nor occupy any volume in the space. So it is clear. Now, first point is we are going to consider here is first of all system. System is defined as a quantity of matter or region in the space chosen for study. Then mass or region outside the system is called as surrounding. Then real or imaginary surface that separate the system from its surrounding is called as boundary. The boundary of system can be fixed or movable. Note that the boundary is the contact surface shared by the both system and surrounding. Mathematically speaking, the boundary has zero thickness. Boundary has zero thickness. Okay. Now our next topic of today's discussion is types of system. What are the different types of system we are going to discuss in this PPT? See, first of all, what is meant by we must have to know what is meant by system. System is a part of universe or a region or matter taken into consideration. There are three types of systems we are going to discuss here. First one is the closed system, which is also known as a control mass or fixed mass. The next system is open system. We are going to discuss here in this PPT. Then control, this open system is also known as a control volume. Keep in mind that these are the very important concept. What is meant by closed system? Closed system is nothing but a control mass, and open system is nothing but a control volume. Keep in mind that because there will be there will be chances of asking such type of objective questions in your competitive examination. What is meant by open system or what is meant by closed system? Or closed system is also known as that dash or whatever may be question. This is also fixed mass is also control mass control closed system is also known as a fixed mass system is also. Then involving flow of mass in open system. The third one is the isolated system. These are the basic three types of system: closed system, open system, and isolated system. See here, the figure in this figure is a closed container is here. M is equal to the mass of the gas, which is constant. You have taken here constant. There is no interaction of mass in this system, and here is interaction of energy. Energy inside the system or outside the system. Energy can cross the boundary of the system. Energy can move inside the system and outside the system from outside the system. But there is no interaction of mass, and this system is known as a closed system. Consists of fixed amount of mass and no mass and cross its boundary. There is no mass can enter or leave the closed system, but energy in the form of heat or work can cross the boundary. And the volume of closed system does not have to be fixed. Volume of the closed system does not have to be fixed. Now, we will move towards the open system. First of all, what is meant by open system? See, in this figure, this is the figure of air compressor. Here, the electric motor is used to run this air compressor. This electric energy is supplied here for rotating this electric motor, and this the work of this electric motor is supplied to run this compressor or reciprocating air compressor. This reciprocating air compressor, the low pressure air is comes inside this inlet of the compressor, and high pressurized compressed air is passed through this pipe to the outside the surrounding. See, this is control surface is considered here. Here, heat is also energy. When we compress the air, the temperature of the air increases, and the heat is crosses boundary from this control surface. And work is also cross heat and work. These are the energy also. Energy interaction is takes place within system and surrounding. And here mass control, mass mass of the air is also coming inside the compressor and going outside the compressor, means there is interaction of mass also takes place. This such type of system is known as open system. Such type of system is known as open system, involving a flow of mass. This system, in this system, involving the flow of masses, both mass and energy can cross the boundary of the control volume. This is known as open system. Now, a special case of the system is known as isolated system. See here, the figure showing that here is a system which is insulated, perfectly insulated from the outside or from the boundary side of the system. There is a perfect insulator, though there is no interaction of energy also. But this insulation is provided for restriction or prevention of energy interaction between system and surrounding. This is known as spatial purpose insulation. This is known as spatial purpose insulation. And this is a closed system. Because of that, there is no interaction of mass inside the system and surrounding. So there is a totally restriction of mass and energy in this system, and this is known as a spatial case of the system or type of system, which is known as the isolated system. An isolated system is one that is not influenced in any way by the surrounding. There is no influence of mass and energy to the surrounding in the isolated system. This means that there is no mass, heat, or work across the boundary of the system. Is it clear? Now we will move towards our the next topic. Our next topic is properties and state of a substance. Properties and state of a substance. See, first of all, we must have to know what is meant by property. Let us suppose there is a system. Let us suppose taken we have considered as a one open system here. This system consists of water. Let us suppose this system consists of water, and we have supplied heat to this system from the bottom side. This is known as a burner. With the help of this burner, we are going to supply heat to the system. Then what will happen? This heat is nothing but the energy supplied to the system. And then what happen? Initial temperature of the system is atmospheric temperature or room temperature, which is we have taken in here 30 degrees Celsius. If we supply heat continuously to the system, then what happens? This temperature changes from T0 to Ti, initial temperature, to T, here means final temperature, and which is we have taken here. The value of final temperature is 100 degrees Celsius. Then what happened? What happened? This is a system. Definitely, this is system. In this system, this is the boundary of the system. Outside this boundary, this is surrounding, and here we, from surrounding, we are going to supply heat to this system by using a burner, which is known as a heat. Now, what happened? This heat supplied to the system may cause change the state of the system or may increase the property of the system. The characteristics of the system is called as any characteristics of the system is called as a property. See, this temperature is a property. It changes from Ti to Tf means 30 degree to 100 degrees Celsius because of heat interaction or energy interaction. Means what happened? The initial state of this water is cold, having a particular volume and particular temperature at initial condition. After some time, when we try to interact this energy, heat energy to the system, then what happens? The state of the system is changed. The state of the system may change, and the state of system is change is observed by using the property temperature. Means initially the water is cold, and after some time the water will be the hot. Means what happened? What is going to inform here? Here we are going to observe here that the temperature of the system is going to increase. Okay. Now some familiar properties are same type of properties are also we are going to consider. First one is the pressure, the second one is the temperature, third one is the volume, and fourth one is the mass. Some familiar properties are pressure, temperature, volume, and mass. Less familiar ones such as viscosity is also one of the property, thermal conductivity is also one of the property, modules of elasticity, thermal expansion coefficient, electric resistivity, and and even velocity and elevation. These are also different types of properties. These are the temperature, pressure, and volume and mass. These are the familiar one, and these are not familiar or that much familiar to in thermodynamics. So the properties are considered as either different types of properties. First one is basic two types of properties. First one is intensive property, and second one is extensive property. The intensive property are those that are independent of the mass of the system, such as temperature, pressure, and density. Keep in mind that this pressure, temperature, volume, then sorry, temperature, pressure, and mass, temperature, pressure, and density. These are the intensive properties. Sorry, and extensive properties are those whose values depend on size or extent of the system. That is total mass, total volume, total momentum are some examples of extensive properties. Now, how to identify the particular property is intensive or extensive? There is one method to identify the property is intensive or extensive. An easy way to determine whether property is an intensive activity is divide the system into two equal parts. The system is divided into, so let us suppose this is a system, this is the system. Here some properties are taken into consideration: mass M, volume V, temperature T, pressure P, and density rho. If we divide this system into two half parts, two equal half parts, then what happen? This is mass is converted M into M1 and M2, and the value of M1 is equal to half M, and value of M2 is equal to half M. Means this half indicate that this is an extensive property. Each part will have same value of intensive property. If value is same, let us say temperature is same for this hub and for this hub. There is no division of this temperature. So this is the intensive property, temperature intensive property. But mass is divided into two parts, half of the m for this part and half of the m for this part. Similarly, volume is also divided into two parts, half v and half v. So this is the this value, each part will have the same value of intensive properties as the original system, but half of the value of the extensive property. Generally, the uppercase letters are used to denote the extensive properties. Generally, the uppercase letters are used to denote the extensive property, and lowercase are used to denote the intensive properties. Keep in mind that. Let us suppose H is the enthalpy denoted by capital H. This is the extensive property. This pressure P is intensive property. Temperature T is intensive property. So there is some exception for pressure and T pressure current because P is indicating generally written as a capital P and temperature generally written as a T. These are the exceptions for the lowercase. And in extensive property also there is major exception for the uppercase. Extensive properties per unit mass is called as specific properties. Some examples of specific properties are specific volume, then specific total energy. These are known as the specific properties. Is it clear? Now, today we are going to stop here. These are some references I have taken. बघू तो पण काय जवळ